Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Ramer-Timon-like carbene insertion, or, more relevantly here, the reaction of haloforms, CHX3, or mixed trihalomethanes with strong base, O generates dihalocarbenes CX2. When a bicyclic compound such as indane, benzene fused with cyclopentane, reacts with a dihalocarbene under basic conditions, the carbene inserts into the 5-membered ring, and subsequent ring expansion or rearrangement can give halogenated benzene derivatives. The key question is which reagent does not produce chlorobenzene. Moving on to the next step. The substrate in all 4 options is indane, a benzene ring fused with a cyclopentane ring. Moving on to the next step. Identify the carbene generated in each case. A. CHCl3 plus HO CCl2 dichlorocarbon. Reaction with the cyclopentane ring of indane, followed by ring expansion, gives chlorobenzene. Chlorine is incorporated into the aromatic ring. B. CHBrCl2 plus HO CBrCl bromochlorocarbon. This carbene contains 1 Cl, so ring expansion can yield chlorobenzene as a product. C. CHBr2Cl plus HO CBr2. Wait, re-examining, CHBr2Cl loses HX with HO. The most acidic proton is removed, the carbene formed is CBrCl from loss of Br or Cl. Actually CHBr2Cl plus HO, CBrCl plus Br or CBr2 plus Cl. The predominant carbene from CHBr to Cl under basic conditions is CBrCl, loss of the better leaving group Br, or predominantly CBr2 if Cl leaves. However, since either pathway can give a carbene containing Cl-CBrCl or not CBr2, ring expansion with CBrCl gives chlorobenzene, while CBr2 gives bromobenzene. Chlorobenzene is still a possible product. D. CHFClBr plus HO carbene. The carbene generated is CFCl, CFBr, or CClBr depending on which halide leaves. Since F is a very poor leaving group, the carbene formed preferentially is CClBr, loss of F is disfavored, or more precisely the base abstracts the proton and then the best leaving group departs. Actually with HO, deprotonation gives carbanion CHFClBr, CFClBr, then loss of the best leaving group. Br is the best leaving group, giving CFCl. Then, CFCl contains F and Cl ring expansion of indane with CFCl would give fluorochlorobenzene derivative, not chlorobenzene, which requires CCl2 or a carbene with 2 Cl, or at least the ring expansion must place Cl in the ring without F. The carbene, CFCl upon ring expansion gives a product where both F and Cl are incorporated, yielding fluorochlorobenzene, not chlorobenzene alone. Since fluorine substitution replaces what would be a chlorine, the product is not chlorobenzene. And for the final step, Y option, D, does not give chlorobenzene, CHFClBr plus HO generates CFCl, loss of Br, the best leaving group. The dihalocarbene, CFCl reacts with indane's cyclopentane ring. Ring expansion gives a benzene ring substituted with F and Cl, i.e., fluorochlorobenzene, not chlorobenzene. No reaction pathway from CHFClBr-HO cleanly produces chlorobenzene because every carbene derived from CHFClBr that contains Cl also contains F or Br, and ring expansion gives mixed halogenated products excluding pure chlorobenzene. A. CCl to ring expansion chlorobenzene directly. B. CBrCl ring expansion chlorobenzene, Cl incorporated, or bromobenzene chlorobenzene is produced. C. CBrCl or CBr to at least one pathway gives chlorobenzene. Therefore, the correct answer is D. Therefore, the correct answer is option D.